Cognizant to the needs of our learners, parents, and teachers, the Department of Education provided us with powerful tools for productivity that will allow us to foster critical thinking skills, problem-solving skills, communication and collaboration skills to be compassionate, responsible global citizens. Join us and discover new ideas in our series of professional development training program with the ICTS EdTech Unit and Microsoft Education Philippines. Together, we will equip our learners and empower our fellow educators for a dynamic future. Para sa bata, para sa bayan, at para sa guro. Sulong Edukalidad. Mabuhay! Good day to all! I am your tutor Madge. Welcome to ETUlay, a free online tutorial, an initiative of the Department of Education, Information and Communications Technology Service, Educational Technology Unit, ICTS EdTech. This program is aimed at helping and assisting learners from kindergarten, senior high school, ALS, Alive and SPED learners. Aside from answering the modules, the ETUlay is offering programs which you will surely look forward to. Together with our parents and teachers, the ETUlay will bridge the gap where difficulty and ease meet in learning new knowledge and skills. So, let us prepare our modules, pen and paper. Ready your mind to see and hear worthwhile and interesting lessons. Let us now study and learn, together with our volunteer online tutors. Tara na!
Ay, magandang hapon po. We're live, Sir Neil.
Magandang hapon po sa lahat ng ating mga live viewers. Good Monday afternoon po sa lahat ng ating nanonood from Luzon, Visayas, and Mindanao. Kamusta po ang ating weekend? Hopefully ay nag-enjoy po kayo.
Welcome to week 3 of quarter 3. Sabay tayong matuto at maging #mahusay sa physical science. Kasama nyo kami, si Tutor Lester.
At ako naman po si Tutor Nel.
Huwag mo kalimutan i-react at i-share ang ating live session ngayong hapon. At, okay. At bago po tayo mapatuloy sa ating kaabang-abang na paksa ngayong hapon, ay atin munang bigyan ng kaunting oras para kilalanin ang ating mga partner schools na ating naging kasama for the past 2 weeks. Pasensya na po kung na-delay man ang aming pagkilala sa ating mga partner schools during week 1, but here it is anyway. So for week 1, maraming salamat po sa ating mga partner schools na aming pong papangalanganan. Maraming salamat sa inyong pong suporta sa ating ETUlay Physical Science live session. At congratulations sa inyong pagiging #mahusay.
Let's call on our Physical Science Partner School for Week 1, Pinagkawitan Integrated National High School from Lipa City, Batangas, Kaibiga High School from Caloocan City, Alibadabad National High School from Isabela,
Padre Garcia National High School from Padre Garcia, Batangas, Luis P. Gomez de Mantina National High School, Cabatuan, Isabela, and Doña Magdalena H. Gafford High School from Echagui, Isabela.
We also have Tumawini Standalone Senior High School from Tumawini, Isabela, Jones Rural School from Cabatuan, Isabela, Partida National High School from San Miguel, Bulacan,
and Aurora Senior High School from Aurora, Isabela. And that is for week number 1.
Para naman po sa week number 2 live session natin, maraming salamat po sa mga sumusunod. Virgen de las Flores High School, Baliwag, Bulacan, Spotswood National High School, Kidapawan City, Cotabato, Padre Garcia National High School, Padre Garcia, Batangas,
Dinapigi National High School, Dinapigi, Isabela, Kaibiga High School, Caloocan City, and Ipil National High School, Ipil Ormoc City, Leyte.
Luis F. Gomez Diamantina National High School, Cabatuan, Isabela, Jones Rural School, Cabatuan, Isabela, Partida National High School, San Miguel, Bulacan,
Tumawini Stand-Alone Senior High School, and San Mariano National High School. At, alright.
Taos puso po ang aming pasasalamat sa inyong mga partner schools sa patuloy na pagsuporta sa aming mga live sessions sa ETUlay Physical Science.
Alright. At ngayon po, tutorial ay papangaralan din natin ang ating mga students of the week for week number 2. So, ang aming pong bibigyan ng pagkilala ngayong hapon ay ang mga taga-subaybay po natin na nagpasa ng kanilang mga output sa activity na ibinigay po namin last week. So, ito po yung mga students of the week. So, from Tumawini Stand-Alone Senior High School ng SDO Isabela, from teacher Joanne Magallones, so we have Kay J. Lu Umakam, Russell May J. Aguada, Jomari C. Bulong, and Jana Marie Esperer.
Also from Tumawini Stand-Alone Senior High School, we have Rachel C. Marignem, Malu L. Rodriguez, Christine L. Guzman, and Mary Grace M. Guiap.
From Tumawini Stand-Alone Senior High School pa rin, we have Emma Marie Mayor, Joanne A. Laman, Dayan Joy Di Madayag, Marj C. Katimbong.
Still from the same school, we have Justin Philip D. Molot.
And last but not the least, from EPIL National High School, at ang guro po ay yours truly, Lester P. Bernardino. At ito po ang aking mga butihing mga mag-aaral from grade 12 section Smartness. Jericho M. Umbal, Renan M. Umbal, and Nia Jane P. Belmoro, all from grade 12 Smartness. So a round of applause po sa ating mga partner schools and students of the week.
So congratulations po. And now we move on to our discussion for this week. For the third week of the third quarter for the school year 2021-2022, we will discuss the topic intermolecular forces. Ang pinagbasihan po ng ating live session ay ang Physical Science ADM module ng Region 4A Calabarzon.
Narito po ang mga learning competencies na ating tatalakayin ngayong araw. So number 1, describe the general types of intermolecular forces.
Number 2, explain the effect of intermolecular forces on the properties of substances.
Bago tayo dumako sa bago nating lesson, recall muna natin ang topics na diniscuss po natin last week. Sa ating huling live session, pinag-usapan natin ang polarity of molecules. So narito ang ilan sa mga importanteng concepts na ating pinag-aralan. A polar molecule is characterized by its unequal sharing of electrons, while a nonpolar molecule shows equal sharing of electrons. And the polarity of a molecule can be determined by taking notes of atoms' electronegativity difference and its molecular geometry.
Aside from the topic about polarity of molecules, we also established that atoms in molecules and ionic substances are attracted to each other either by sharing or complete transfer of electrons. Can you recall what are these forces or bonds that keep the atoms in a substance attracted to one another? That is correct. Atoms in a molecule or ionic substance stay attracted to one another because of chemical bonds. This can either be covalent or ionic. This attraction between molecules are called intramolecular forces.
Now that we are aware that there are forces of attraction between atoms in a molecule, so do you think there are also forces of attraction that exist between molecules? And the answer, of course, is yes. So, and these forces will be the center of our discussion today. These are called intermolecular forces of attraction.
By definition, intermolecular forces are attractive forces present between molecules. They are important because they determine some physical properties of molecules like boiling point, melting point, and density. There are different types of intermolecular forces. These are the following. We have van der Waals forces, which includes dipole-dipole interaction, dipole-induced dipole interaction, dispersion forces, and we have ion-dipole interaction, and the third one is hydrogen bonding. Lahat ng ito ay ating i-discuss ngayong hapon. Samahan nyo kami ni Tutor Lester as we discover more information about these IMFAs.
For the first type of intermolecular force of attraction, let us talk about van der Waals forces. The first one is dipole-to-dipole interaction. This force is present in polar molecules, and through constant movement, the changes of the molecules align in such a way that the partially positive end of one molecule is attracted to the partially negative end of another molecule. An example of a dipole-to-dipole interaction is the intermolecular force of attraction that occurs between hydrogen chloride molecules. So sa illustration, makikita natin ang dalawang hydrogen chloride molecules. Based on our discussion last meeting, we were able to establish that hydrogen chloride is a polar molecule, meaning mayroon siyang partially positive at partially negative sides. At dahil alam naman natin na opposite charges attract, kapag mayroon ka pang isang hydrogen chloride molecule, ang partially negative charge ng isang molecule ay maa-attract sa partially positive side ng isa pang molecule. Ang interaction nito ay tinatawag na dipole-to-dipole interaction dahil ito ay nangyayari sa pagitan ng dalawa o higit pang dipole molecules.
Another type of van der Waals force is the dipole-to-induced dipole interaction. This force occurs when a polar molecule interacts with a non-polar molecule. The partial charges in the dipole causes the polarization of the other molecule. In this manner, the electron arrangement is disturbed. These give rise to regions of partial positive and negative poles. The induced dipole will then be attracted to the original polar molecule, resulting to dipole-induced dipole interaction. An example of dipole-induced dipole interaction is a force of attraction between water molecule and an oxygen molecule. In the illustration, you will see two different molecules, the water molecule and the oxygen gas molecule. Based on our discussion last meeting, we know that water is a polar substance, meaning it has a partially positive and negative sides. Oxygen gas, on the other hand, is considered as a non-polar molecule. So, kung non-polar ang oxygen gas, paano siya nagkaroon ng partially positive and negative sides? Ito ay dahil sa polarity ng water molecule. Kapag ang isang polar molecule ay lumapit sa isang non-polar, nadi-disrupt nito ang distribution ng electrons ng isang non-polar molecule. Dahil nga mayroong partially positive at negative sides ang isang polar molecule, nagre-react ang mga electrons ng non-polar base sa side kung saan sila malapit. Kung ang partially positive side ng polar molecule ang mas malapit sa non-polar, ang tendency ng electrons ay pumunta towards the side where the polar molecule is. Kapag naman ang negative side ang mas malapit sa isang non-polar, kagaya na nasa larawan, ang tendency naman ng electrons ay lumayo at pumunta sa kabilang side. Tinawag itong dipole-induced dipole dahil ito ay nangyayari sa pagitan ng isang polar molecule na mayroong dipole at isang non-polar molecule kung saan nagkakaroon ng induced dipole. Sa Tagalog, ang ibig sabihin ng induce ay sapilitan. Dahil sa kahit na wala namang talagang dipole moments ang isang non-polar, napipilitan itong magkaroon ng dipole dahil na rin sa presensya ng isang polar molecule.
The last of the van der Waals force is the dispersion force. It is also known as the London dispersion force. So this force occurs between two or more non-polar molecules. At any given time, the electron distribution may be uneven and results to an instantaneous dipole. Yung instantaneous dipole o temporary dipole will then influence the neighboring atoms through attractive and repulsive forces. So eventually, these substances will gain instantaneous dipoles too. Attraction between opposite charges will happen among the species present. So let's have a closer look kung paano nagkaroon ng London dispersion force. Alam naman natin na ang mga nonpolar molecules ay walang partial charges. So paano magkakaroon ng attraction between the nonpolar molecules kung wala naman silang partial charge? So ang sagot, sa pamamagitan ng tinatawag nating instantaneous dipole or temporary dipole. So based on our understanding, we know that electrons continuously move around. May mga pagkakataon na magkakaroon ng mas maraming electrons on one side of the molecule kumpara sa kabila. Kapag nangyari, ang side na kung saan nakakonsentrate ang karamihan ng mga electrons ay magkakaroon ng temporary partial negative charge. Samantalang ang side naman na kakaunti ang electrons ay magkakaroon ng temporary partially positive charge. Importanteng isaisip natin na ang pangyayaring ito ay temporary lamang dahil nga sa laging paggalaw ng mga electrons sa loob ng molecule. So, base sa illustration, makikita natin sa una at pangatlong pares ng molecules, makikita natin na hindi symmetrical ang arrangement ng electrons sa loob ng molecules. At dahil dito, nagkaroon ng temporary dipoles ang mga molecules. Kapag nagkaroon ng temporary dipoles, maa-attract at opposite partial charges sa isa't isa. Ang tawag sa attraction na nangyayari sa kanila ay London dispersion force.
Okay pa ba tayo mga viewers? Meron ba kayong mga bagong knowledge na nakuha sa ating discussion so far with regards to IMFA? Bago tayo mag-proceed, i-summarize muna natin ang tatlong van der Waals forces na ating napag-usapan. Mayroon tayong dipole-dipole interaction na nangyayari sa mga polar molecules. Mayroon din tayong dipole to induce dipole na nangyayari naman sa pagitan ng isang polar at non-polar molecule. At ang panghuli ay ang London dispersion force na nangyayari naman sa pagitan ng mga non-polar molecules.
And now, let's talk about ion to dipole interaction. This interaction results from the attraction between either a cation, which is the positive ion, or an anion, which is the negative ion, with permanent polar molecules. So the ions will be attracted to the opposite charges present in the dipole, resulting to this type of attraction. This type of intermolecular force of attraction is usually found in solutions of ionic compounds in polar liquids. So ang example po dito is a solution of salt and water. Kagaya ng nakikita nyo po sa illustration, we have here the sodium ion, which is a positive ion that is surrounded by water molecules. At kung mapapansin nyo po, ang mga partially negative charge ng water molecules ang nakaharap malapit sa sodium ion. The interaction between the sodium ion and the water molecules is an example of ion to dipole interaction.
And for the last one, we have hydrogen bond. Hydrogen bonding is a special type of dipole-dipole interaction between the hydrogen atoms in a polar bond. It requires that the hydrogen atoms in the molecules be bonded with a more electronegative atom such as oxygen, nitrogen, or fluorine to form hydrogen bonds with other molecules. So, dahil nga ito ay isang uri ng dipole-dipole interaction, ito ay nangyayari din sa pagitan ng mga polar molecules. Narito ang halimbawa ng mga molecules na mayroong hydrogen bond. Sa water molecule, makikita natin na ang hydrogen ay isang molecule ay attracted sa oxygen ng isa pang molecule. Sa pangalawang example naman, mapapansin ninyo na ang hydrogen mula sa water molecule ay attracted sa nitrogen ng ammonia. Tandaan lang po natin, ang hydrogen bond ay nangyayari lamang kung ang hydrogen ng isang molecule ay attracted sa oxygen, nitrogen, or fluorine ng isa pang molecule.
Ayan, Tutor Nel. So natapos na natin i-discuss ang iba't ibang uri ng intermolecular forces of attraction. Atin muling i-summarize ang ating mga napag-usapan kanina. So, dispersion forces exist between nonpolar molecules. Ion to dipole interaction exists between ion and polar molecule. And hydrogen bond exists between the polar molecules where hydrogen must be attracted to oxygen, nitrogen, or fluorine of another molecule.
And we also have dipole-dipole interaction, which occurs between polar molecules, and dipole to induced dipole interaction, which happens between polar and a non-polar molecule. Ayan. Ngayon naman, let's have a simple activity para naman malaman natin kung talagang naintindihan natin ang discussion about IMFA. Determine the intermolecular forces of attraction that occurs between the following molecules. Number 1, hydrogen chloride and hydrogen chloride. Number 2, nitrogen gas and nitrogen gas. Number 3, water and chloride ion. Number 4, ammonia and ammonia. And number 5, methane and carbon monoxide.
Okay, so I guess we should give them at least a minute or two in answering the activity. So habang nagsasagot po kayo sa activity na nakikita nyo po ngayon sa inyong mga screen, babatiin po muna natin ang ating mga masugid na taga-subaybay dito sa ating ETUlay live session. Right, maghanap tayo dito sa comment section, Sir Neil. Right. Alright, magandang hapon. Okay, good afternoon to Mary Grace Giyab from grade 12 Amethyst, Tumawini Stand Alone Senior High School. Magandang hapon din po sa kanyang teacher na si Miss Joanne L. Magallones. And okay, babatiin ko rin ang aking mga butihing mag-aaral sa ETUlay National High School. Okay, we have here from grade 12 Smartness, Laarni Mandras. Okay, so this is from ETUlay National High School from SDO Ormoc City. And we also have here Carleo Lamadrid Ubinya, okay, from San Mariano National High School, SDO Isabela.
Yan. Meron din tayo dito, no, yung una nating live viewer, si Carissa Chavez from grade 11 Excellence from ETUlay National High School din, Ormoc City, Region 8. Yan. Good afternoon po sa inyong lahat.
Alright. So, let us proceed po by answering the activity. Ayan, excited na ho ba kayo?
So, let us answer the first item. In answering, we need to determine first the nature of the substances involved. You need to ask the following question. Is the substance polar or non-polar? So, in this case, hydrogen chloride is a polar molecule. At base po sa ating discussion, ang mga polar molecules ay maaaring magkaroon ng dipole-dipole interaction or hydrogen bond. At dahil chlorine ang ka-interaction ng hydrogen sa ating first example, we can easily assume that the IMFA acting on hydrogen chloride is dipole-dipole interaction.
Ayan. So for number 2 naman, again, we identify the polarity of the substance. The nitrogen molecule, or ETU, is considered as a non-polar molecule. And all of the intermolecular force of attraction na diniscuss natin, the one that occurs between two or more non-polar molecules is dispersion force.
For number 3, we have two different substances. The first one is a water molecule, which is a polar molecule, and the other one is a chloride ion, which is a negatively charged ion. Therefore, we can conclude that the IMFA between these two is ion-dipole interaction.
In number 4, we have two molecules of ammonia, or NH3. And based on our understanding, ang ammonia is a polar molecule. Looking at the example more closely, you will notice that the hydrogen from one ammonia molecule will be attracted to the nitrogen of the other ammonia molecule, making this interaction a hydrogen bond.
And for the last number, we have methane molecule attracted to carbon monoxide molecule. Determining the polarity, CH4 or methane is non-polar while carbon monoxide is polar. Therefore, the IMFA between the two should be dipole-induced dipole interaction.
And now that we know how to identify the intermolecular forces of attraction present between molecules, here is another question that we need to ponder during our discussion. So, what is the importance of knowing the intermolecular forces of attraction? Can they be used to predict the properties of a substance? And the answer, of course, is a big yes. So ang intermolecular forces of attraction, this brings about some of the physical properties of the substances, such as surface tension, viscosity, boiling point, melting point, and freezing points, and solubility. As we continue our discussion, you will learn how intermolecular force of attraction affects these properties and why substances behave differently from one another.
The properties of substances as viewed on the macroscopic level can be explained by the types of intermolecular forces present between and among substances. So, for the following sections, we are going to discuss how IMFA affects some of the physical properties of substances. To understand how this IMFA affects the properties of substances, we need first to be familiar with the relative strength of these intermolecular forces. Sa diagram, makikita natin kung paano na-arrange ang mga intermolecular force based sa kanilang strength. So ibig sabihin, ang pinakamahinang intermolecular force ay ang London dispersion force, followed by the dipole-induced dipole, and then the dipole-dipole interaction. Ang hydrogen bond ay ang second strongest, while the ion dipole is the strongest among the five. Please take note of this because we will need this to understand more the concept that we are going to tackle.
The first physical property that we are going to talk about is the surface tension. It is the amount of energy required to stretch the surface area of liquids. Liquids with high intermolecular forces tend to have high surface tensions. So when water is dropped on a waxy surface, it tends to form a round bead to minimize the surface area that it occupies. And as you can see in the picture, pag ang tubig po ay pumatak sa isang waxy surface, nakakabuo po ito ng isang rounded na shape. So this can be explained by the surface tension of water. And an example of surface tension is the capillary action. It is the ability of liquid molecules to move against gravity. The forces bringing about capillary action are cohesion, which is the intermolecular force of attraction between like molecules, and adhesion, which is the attraction between unlike molecules. Water molecules exhibit cohesion while the attraction between water and the sides of the glass tube is adhesion. If adhesion is stronger than cohesion, the liquid is pulled upward. If cohesion is greater than adhesion, then there is a depression or lowering, resulting to a lower height of the liquid in the capillary tube. Always remember, the stronger the intermolecular forces possessed by the molecules, the higher is the surface tension of the substance.
Ayan. Another property is viscosity. This is a measure of liquid's resistance to flow. The greater the viscosity of a liquid, the more slowly it flows. The strength of IMFA affects the ease with which substances flow. Liquids that have high IMFA are highly viscous. The presence of strong hydrogen bonds in liquids makes the substances highly viscous. In Tagalog, when you say liquid is viscous, it means ito ay malapot. In the picture, there are different liquids with different viscosity. So, alam naman natin na mas malapot ang honey compared sa tubig. So, we can assume na mas mataas ang IMFA ng honey kaysa sa water. Another example is the difference in viscosity of glycerol and water. The leads of glycerol below shows 3 OH group that can participate in hydrogen bonding, whereas water has only 1 OH group to form hydrogen bonding. Glycerol is more viscous than water.
Now let's talk about the boiling point and melting point. Boiling point depends on the equilibrium vapor pressure. So this means that the rate of vaporization is equal to the rate of condensation of this substance in a closed container. Vapor pressure depends on the intermolecular forces present in the substance. So when the intermolecular forces are strong, the vapor pressure is low. So as a consequence, boiling will occur at a higher temperature because more energy is needed to break the intermolecular bonds for the substance to change into water vapor. Let us take, for example, the comparison of boiling points between water and methane. Water has a boiling point of 100 degrees Celsius, whereas methane has a boiling point of negative 162 degrees Celsius. The difference in their boiling points is brought by the difference in their intermolecular force. The hydrogen bond is much stronger compared to dispersion forces of methane. This condition is also true for the melting point. The ease with which bonds breaks affects the melting points of substances. The greater the intermolecular forces, the greater the intermolecular force that exists among the molecules, the higher is their melting point.
Yeah. The last property that we are going to talk about is solubility. Solubility is the ability of substance to dissolve in a given substance. The amount of any substance dissolved in a solvent, that is the substance that dissolves another substance, depends on the types of interactions among molecules, pressure, and temperature. The rule like dissolves like applies to solubility. This means that the kind of substances being dissolved should exhibit the same properties or should be compatible from them to form solutions. The polarity of molecules is an example factor for substances to dissolve in certain molecule. So, ang tendency, kapag polar ang isang solvent, kaya lang nitong tunawin ang isang polar na solute. At ganun din naman sa non-polar. Ang non-polar solute ay nadidissolve lamang sa non-polar solvent.
Alright. So for your activity na gagawin nyo po mamaya, you may choose which of the following molecules, ammonia, water, and hydrogen fluoride would display the strongest hydrogen bonding. And paki-explain na rin po. So, batiin muna natin ang ating mga live viewers. Alright. Hanap po tayo dito sa comment section.
May mga nadagdag ba sa ating mga
may
live viewers ngayon?
Yes, marami pong nadagdag, Sir Neil. Alright, so we have here Julia Jane Eblamo, Silidio. Okay, from section Greatness, ETUlay National High School. And Miss Jonaline Alapitan from grade 12 Amethyst of Tumawini Standalone Senior High School.
We also have Hanilet de Guzman Baracao from grade 12 TVL, Natalna, Jones Rural School. Teacher po niya si Ma'am Gemaline Fronda.
Babatiin po namin ang lahat ng aming mga live viewers from Luzon, Visayas, and Mindanao na sinasabayan po tayo sa pagkatuto para maging #mahusay sa physical science.
So, you may submit your output po in any of the digital formats sa link na nakikita nyo sa ating screen. So, the link is https://bit.ly/351fi2j. Enter your name, your grade and section, name of the teacher, school, and SDO, and upload your output to be recognized. The output can be in any format possible, like Word, PDF, or JPEG. Hihintayin po namin ang inyong mga submissions, mga live viewers.
And now, let us move on to our quiz segment entitled Gets Mo, Sagot Mo. So sa segment nito, may sasagutan po tayong 5 katanungan na nanggaling of course sa ating pinag-usapan kanina. We are inviting you all, our live viewers, to have fun at sumali po kayo sa ating Gets Mo, Sagot Mo segment. So comment nyo lamang po ang inyong sagot sa comment section. So alright, so let's get started na po.
For number 1, it is an intermolecular force that occurs between 2 or more non-polar molecule. A. Dispersion force. B. Ion-dipole interaction. C. Dipole-dipole interaction. Letter D. Dipole-induced dipole interaction. The answer is letter A. Dispersion force. Number 2. When a chloride ion is dissolved in water, in what part of the water molecule will the chloride ion be attracted to? A. In between the bonds. B. Partially positive side. C. Partially negative side. And letter D. Chloride ion is insoluble in water. The answer is letter B, at the partially positive side. Kung matatandaan po natin, chloride ion is negative and therefore is bound to be attracted to the partially positive side of the water molecule, which is the hydrogen atom. Number 3. Which of the following molecules would have a hydrogen bond with its own type of molecule? A. carbon monoxide, B, hydrogen chloride, C, hydrogen fluoride, and letter D, phosphorus pentachloride. The answer is letter C, hydrogen fluoride. Why not letter B? As mentioned in the discussion earlier, hydrogen has to be bound with a more electronegative atoms like oxygen, nitrogen, and fluorine. It is in these atoms that hydrogen will form a hydrogen bond. Chlorine atom in letter B does not fit the bill, but letter C does.
Okay, for question number 4. Which of the following properties decreases as the intermolecular force of attraction gets stronger? Letter A, viscosity, B, solubility, C, boiling point, and D, vapor pressure. Ang tamang sagot po ay letter D, vapor pressure. For question number 5, which of the following substances would have the highest boiling point? A, oxygen molecule, B, carbon dioxide, C, CH4 or methane, and D, formaldehyde or CH2O. Ang tamang sagot po ay letter D, CH2O or formaldehyde. So what makes letter D or formaldehyde as the substance with the highest boiling point? So all of the choices except letter D are non-polar molecules. So polar molecules always has a higher boiling point than non-polar ones.
Yan. So, before we end this session, ito pong ating paksa na tinalakay ngayong hapon ay nakabase sa content ng Physical Science ADM Modules 5 and 6 ng Region 4A Calabarzon. Salamat po sa inyong pagsama sa amin sa nakaraang 40 minutes na umaatikabong live session patungkol sa intermolecular forces. We are inviting everyone to send us their feedback because it matters to us. If you are using a device with a QR code scanner, you may scan the code na makikita nyo po sa inyong mga screen. Or you may screenshot this screen for you to scan it later. You may also type in your web browser the link displayed at the bottom area of the screen. That is tinyurl.com/ETUlay feedback form. Again, that is tinyurl.com/ETUlay feedback form.
You may also send your words of appreciation po using the link given. You can also give recommendations as to sino po magiging guest natin during our next live stream. You may also email your comments and suggestions through the email na nababasa nyo po sa inyong screen. edtech@deped.gov.ph.
Inaanyayahan din po namin kayo, aming mga minamahal na mga live viewers, na sabayan din po ang ating mga tutors sa General Biology 2 na sina Tutor Easter ng SDO Caloocan City at Tutor Tina ng SDO Pasig City after this session po from 4:40 to 5:20 p.m.
You may also watch the live session in Empowerment Technologies kasama ang ating mga tutor na sina Tutor Jane of SDO Puerto Princesa City at Tutor Janelle ng SDO Ilocos Sur right after this session from 4:40 to 5:20. And that's it for week number 3. So, congratulations po sa lahat. So, enjoy po natin ang the rest of the week kasama ang iba't ibang tutor sa iba't ibang asignatura. So, kita-kita po ulit tayo sa Lunes sa parehong oras from 4 to 4:40 in the afternoon. So, this is your tutor, Tutor Lester from SDO Ormoc City.
And yours truly, Tutor Ronel from SDO Pasig City.
Goodbye, and be well.
God bless.
Ang husay naman! Natapos mo ang iyong tutorial session kasama ang iyong mahusay na ETUlay tutor. May bago ka bang natutuhan? I-share na yan gamit ang #ETUlay Level Up. Huwag aalis ha, dahil may susunod pang programa na pwede mo ring panoorin at salihan. Dahil naghihintay na ang iyong mga tutors. Happy learning dito sa ETUlay!